Hello and welcome back. In this problem, we're going to go through and find another integration by substitution, but this time around, we have to be very careful with what we do. So for starters, let's pick our u. So we're going to let u equal 1 minus x. So then the derivative dux will be negative 1. So dx is equal to negative du. So going back into our problem, the original x squared is going to stay. We've got the square root. The 1 minus x is replaced with u. And then we also have a negative du. So when you look at this problem, you're going to be kind of frustrated, at least you should be, because you notice that you have both u's and x's mixed up in the same integral. And there is no way to go further with two different variables and one single integral like this. So we're going to do something extremely clever. We're going to actually go back to our original substitution, and we're going to take that x squared and rewrite it in terms of u. So over here, you will notice that if u is equal to 1 minus x, then u plus x is equal to 1, and x is the same thing as 1 minus u. So you can swap out that x with a 1 minus u instead. So that's the integral of 1 minus u times the square root of u, and there's still a negative du back here. So if we go through and multiply that negative 1 in, we'll just reverse the subtraction order. So that's u minus 1, and that was squared, square root of u du. And you might be tempted to do another substitution, but you'll just go back in circles. So we don't want to do that. We want to actually go forward with this problem. So the first step in doing so is to actually square out that u minus 1. So that's going to be a u squared minus 2u plus 1. That's still times the square root of u, but let's rewrite that as u to the half power. And now you'll notice our strategy. We're going to go through and multiply that in, and then integrate term by term. So if we take a 2 and add a half to it, that's going to make 5 halves. So that's u to the 5 halves is our leading term. If we take a u to the first power, add a half, we get 3 halves. And then back there, it's going to be plus 1 and a u to the 1 half. All respect to u. That was a half, not a u. That was a silly little mistake to make right there. So that's a half. That is not... There I go again with the highlighter. Go back to pad, the eraser. All right, so there we go. 1 half du. All right, so now let's hit it with our power rule. And again, we're going to be adding 1 to all these exponents and dividing by the new exponents. So that's going to be u to the 7 halves divided by 7 halves minus 2 times u to the 5 halves divided by 5 halves plus u to the 3 halves divided by 3 halves plus arbitrary constant c. And now we're going to multiply by the reciprocals. So we're going to have a 2/7 u to the 7 halves minus 4/5 u to the 5 halves plus a 2/3 u to the 3 halves plus c. And one thing you can do nicely in this problem, if you wanted to, is you could actually factor out a u to the 1 half. So that's going to give you 2/7 u to the 3rd minus 4/5 u squared plus 2/3 u to the 1st plus c. Remember that when you multiply, you add exponents. So 3 plus 1 half does make 7 halves. 2 plus 1 half does make 5 halves. And 1 plus 1 half does make 3 halves. Just kind of checking as we go. Next thing you can do is you can replace. Remember, u this whole time was 1 minus x. So this is going to be the square root of 1 minus x times the polynomial 2/7 1 minus x cubed minus 4/5 1 minus x squared plus 2/3, 1 minus x to the first power plus c. And that's actually a perfectly simplified answer because we do have everything back in terms of x. You could go a lot further with this, of course, though. You could factor out a common 1 minus x, take that polynomial and simplify it all down. But in any case, we did find our indefinite integral of our original problem. So just to kind of backtrack a little bit, every once in a great while, you will have to go in and rewrite your variable x in terms of the new variable u. And so that's what we had to do here in this problem. To go further, just remember that when you have a mixed bag of variables, 2, maybe 3, not good for Calc 1. We can handle that stuff later, but in Calc 1, the idea is to just get it all in terms of one single variable before you integrate, and don't leave a mixed combination.